Assalamu alaikum. In this video, we discuss the second part of our chapter, Radioactivity. The main objective of this part are: know the type of radioactivity, know some properties of radiation and particles, write a nuclear reaction by applying laws of conservation. In the previous part, we discussed the type of a nuclear reaction. We have seen that there are two types: provoked like fission and fusion, and spontaneous like radioactivity. The provoked nuclear reaction takes place due to external intervention, while radioactive reaction takes place spontaneously and without any external intervention. In radioactive reaction, the parent nucleus is decayed into more stable nucleus with the emission of particle and radiation. The general equation of radioactive reaction is given here, and atom X is decayed into more stable atom Y, accompanied with emission of particle and radiation. Also, we have seen that the radioactive reaction can be artificial or natural. And the last objective that has been discussed was Soddy's law, in which we have seen that the mass number and the atomic number are conserved. There are four types of radioactivity based on the type of the emitted particles. And note that each radio element has a specific type of radiation that can be emitted. In other meaning, it is not a choice for the radio element to emit this type or that type. The first type that we discuss here is alpha. It is the emission of an alpha particle atom by the parent nucleus. This decay is characteristics of heavy nucleus. The name and the symbol of alpha particle is helium-4-2. It has low speed because it is heavy particle. It is also positively charged and it has low penetrating power. I will explain this penetrating power in the next slide of this video. The general equation of nuclear reaction in case of alpha decay is given here. An atom X is decayed into Y atom with the emission of helium atom. An example about alpha decay is shown here. Polonium-210 is decayed into lead-206 with the emission of helium. We can see that the polonium-210 loses 2 protons and 2 neutrons to form a new more stable nucleus called lead-206 with the emission of helium. In this animation, we can see clearly that the decay of radium-226 is alpha type. It loses 2 protons and 2 neutrons to form a new atom called random with the emission of helium. Second type of decay is beta minus. It takes place when an electron is emitted from the atom because a neutron becomes a proton. The name of beta minus particle is electron and it is denoted by E0-1. It has high speed compared to the alpha particle and it is negatively charged, and it has 100 times more penetrating power than the alpha particle. The general equation of beta minus decay is shown here, and atom X is decayed into atom Y with emission of an electron. An example is shown below. The carbon-14 is beta minus radioactive element and it is decayed into nitrogen-14 with the emission of an electron. This animation shows clearly how the thorium atom is an example on beta minus decay. A neutron of the thorium atom is converted into proton or become a proton, which led to the ejection or emission of an electron. This led to the formation of a new element called protastinium with emission of an electron. The third type is beta plus, in which positron particle is emitted. The name of beta plus particle is positron and its symbol is E0+1. It has the same speed and the same mass as an electron, but it is positively charged and it has average penetrating power like the beta minus particle. The general equation of beta plus decay is given here, and atom X is decayed into Y atom with the emission of a positron. The nitrogen-13 is a beta plus radioactive element. it decays into carbon-13 with the emission of a positron. In a beta plus decay, the atom loses a proton because it is transferred into proton, which led to the emission of a positron particle as shown here in the case of the sodium element. We can see that the sodium nucleus loses a proton to become a neutron, which causes the emission of a positron. The final type is the gamma decay. It is due to the excitation of the daughter nucleus from high energy level to lower one. It is an electromagnetic wave and it propagates at the speed of light. It has no mass and no charge. Also, it has high penetrating power. The general expression of gamma decay reaction is given here. An atom X is born in excited state, is decayed into the same atom but in the ground or lower state with the emission of gamma radiation. Note here, this star with parent nucleus indicates that the atom is born in excited state. When a daughter nucleus born in an excited state, an electron will de-excite from high energy level to lower one. This difference in energy level will appear in the form of ejection of radiation called gamma. As shown in this animation, this atom is born in excited state, it de-excites, and we can see clearly the emission of the gamma radiation. However, if the atom is born in the ground state, then no emission of gamma radiation takes place. In this slide, we discuss the penetrating power of each ejected particle or emitted radiation. It is clearly that the gamma radiation has the highest penetrating power because it penetrates the three walls, paper, aluminium, and lead. This high penetrating power arises from the characteristics of the gamma, since it is massless and uncharged, and also it propagates with the speed of light. The beta particles have more penetrating power compared to alpha particle, and less penetrating power compared to gamma radiation. They penetrate the two walls, paper and aluminium, while alpha particle has the lowest penetrating power since it penetrates the paper wall. Let's solve the following application. We have different radiative equation as shown here. We have to complete the equation and to indicate the type of each decay. We apply Soddy's law to find the missing Z and A. We apply law of conservation of atomic number and law of conservation of mass number. In first equation, we have 84 proton and it is equal to X plus 2. I can solve X and I get 82 proton. In the same way, for the mass number, we have initially 210. This 210 is equal to Y plus 4. Then Y is equal to 210 minus 4. It is equal to 206. Then the equation becomes polonium 210, 84, disintegrate into lead 206, 82, plus helium 4, 2. And due to the emission of helium, this type of decay is called alpha decay. For the second equation, we apply the same laws. We have 27 proton is equal to X plus 1. I find X and it is equal to 26. In the same way for the mass number, we have 53 plus 0 is equal to Y, then Y is equal to 53. The equation becomes cobalt 5327, disintegrate into iron 5326, plus positron 0 plus 1. And due to emission of this positron, the type of this radioactive reaction is beta plus. For the last question, we apply also the Soddy's law. We find first the missing particle. We have phosphorus 32 is decayed into sulfur 32 plus unknown particle. We apply the conservation of atomic number. I have 15 is equal to 16 plus X, then X is equal to minus 1. In the same way for the mass number, I have 32, this 32 is equal to 32 plus y, then y is equal to 0. Then the type of this unknown particle is electron, 0 minus 1. So the type of decay of this equation is beta minus decay. In the summary of part 2, we have discussed the different type of decays. We discussed the alpha decay, and such kind of decay takes place when a helium atom is emitted. This particle is positively charged and it has low penetrating power. Also, we discussed the beta minus decay, and such kind of decay takes place when an electron is emitted. It has an average penetrating power and it is negatively charged. Also, we have seen there exists a beta plus type, and this kind takes place when a positron is emitted. It is positively charged and it has average penetrating power like beta minus. Also, we have seen that the gamma decay, and it is due to de-excitation of daughter nucleus. It is an electromagnetic radiation with no mass and no charge. It has the highest penetrating power and it propagates with the speed of light. At the end, please watch this video many times and contact your teacher for any further information. Wassalamu alaikum wa rahmatullahi wa barakatuh.